So in the previous tutorial, I think we left off from weapon firing line traces. So we have the capability of firing weapon. Actually, it's currently doing some sort of line tracings, but yeah, we can further improve this thing. But before going back to the weapon fire, I think like you may need to implement sort of player camera logics, right? For example, like let's say I just added some camera offset to here. Now it's sort of like not under the expectations, right? So instead of like manually hard coding the camera offset values like this, I think it would be nice to have sort of a player camera manager that is dedicated to handle the camera manipulations, right? So let's add that thing now. So to get started, we have to create the player camera manager. So inside TPS game directory, I'll create a new folder called camera, because like there are multiple different stuff that we need to be added to this specific camera feature. So I'll organize all of those stuff at this folder, right? So first let's create a blueprint class which comes on the camera manager, player camera manager, right? And I'll call this one as BP camera manager, right? And this one should basically inherit from the parent camera manager class, which has sort of like default features relevant to those camera manipulations. And in order to use this one, we can plug it to the game base. So in the game base, actually we have this TPS game mode, and there is a field called no, not here specifically. I think it's inside the player base. So let's go to the player base and search for no sorry, not here as well. I think it's under player controller. It's the game base player controller. Okay, here we have the field called player camera manager class. So let's select the BP camera manager, and ideally what will happen is that camera manager is correspond with this player controller, and this player controller is attached over here as the player controller class. And this game mode is a default game mode that we are currently having. So whatever the player base that we specify here will automatically have that reference to that specific camera manager, right? So just to test that thing, maybe we can print it as hello text at the camera manager. Right, maybe you can see it on the console. See, the hello has been printed, right? So I'll close other stuff for now, and I'll keep open this one, BP camera manager, because we are going to implement like a set of logics in order to control our camera, right? So the first thing I need to do to reset the offset that we added at the player camera, so select the spring arm and we can get rid of this offset. All right, and then at the camera manager, yeah, we can. I don't need this tick and begin overlap stuff. I'm just interested in this begin play. So here let's get the player pawn, right? And let's get the character as well, and I'll promote it to variable called owner character. And then we need to determine this character is the player, because ideally like the camera manager is needed for the player, but let's say if this one is used for multiple different play controllers, like we don't need to actually consider those stuff. So maybe like you can check whether this one is a player or not, but for now I will just keep as it is. And then since I'm going to manipulate the spring arm and the camera, maybe we can get those reference to here, right? So how to get that? So I'll get the player pawn, or maybe I can get the owner character, and let's get component by class. This should be the type of spring arm component. Now promote this to a variable called spring arm. Similarly, let's get another component which is camera component. Let's promote it to a variable called camera. Right now, since we have those reference, really we should be able to manipulate those variables, right? Yeah. For now, in order to show you how this works, maybe I'll show you how we can manipulate this spring arm target arm length. Right. So I'll create a dedicated function for that. Create a function here called set spring arm. No, I think the function will not do it. Yeah, I'll create an event called maybe update spring arm length. Right. So first we have to get the spring arm reference, and I'll convert it to a validated get, and then we can get its target arm length. No, not the get, actually we can set the target arm length to a given value. So currently it's 400, like you can see here, and maybe I will make it as 1000 just to show you like how it works, right? And this event, you can call it here at the begin play. It will be applied. Now you can see the target arm length is somewhat 1000, right? Or like if you need a closer location, then you can manipulate it like here, maybe like 100. You can see it's too much closer, right? But by default I'll keep it as 400, and it will be in this position, right? So if we manually update the target arm length or whatever the value that we want, then it's sort of like static, right? Which means like each time when we need to make some change, either we have to initialize these values manually, or like we need some sort of different events that is being called back to initialize these values. But either way, like I don't think these sort of manual initializations will work. Instead, I think it would be nice if we can have sort of like a data oriented architecture where we can quickly toggle in between multiple different camera states, right? So when we are switching in between multiple different camera states, automatically these values will be configured properly, right? So we don't need to actually worry about these independent values at each time, right? Okay, so in order to do that, first I need to explicitly say what sort of a camera states that I've been having, and I came up with set of camera states. So I'll add those stuff as an enumeration. So first I'll create a new folder called camera under the enums folder, and there let's create an enumeration called e underscore camera state. Right. So I have like a set of camera states currently, so I'll add those stuff to here. Let me quickly look at my documentation. Okay, so I came up with 5 different camera states. So I just directly add those stuff within this enum right now, and later on like we can configure those stuff properly, right? So the first type of camera is medium camera, which is like the default third person camera, right? So I'll edit like this: default third, or maybe like we can edit as a description. I'll say default third person camera. And the second type is basically close-up camera, which is like when we are at the combat mode, we should have sort of like a closed up camera, right? So I'll make this as combat mode camera. And we need like sort of aiming camera. I will mark it as aiming camera, which is at combat aiming mode. Or like simply let's say aiming mode camera. And then we can have far camera, which is like sort of cinematic camera, or like let's say whenever we're driving a vehicle, or I don't know, maybe like whenever we climb a ladder, then we can have this far camera. So it sort of visualize the entire area instead of focusing on the targeted character. So I'll add a description like exploration mode, or like vehicle exploration or vehicle mode camera. And additionally, like we can have a sprint camera, right? So which is sort of like a generic camera movement or camera transitions when the characters start to sprint, right? Sprinting camera. Okay, so these are the 5 types that I came up with, but based on your requirement you can add any sort of a camera state, right? And then let's create a data structure. So to do that also, like, I will create a new folder first called camera, and there let's implement a blueprint structure, and I'll call this one as S camera settings. Right. That's the camera settings. Obviously we should have what we should know, like what sort of a camera state that we are having. So I'll add that field called camera state. The type of camera state. Also, I'm going to manipulate the spring arm length. Therefore, let's add another field called spring arm length, which is actually the type of float. Also, we can manipulate the camera location. And to do that, I will add a new field called camera location, which is the type of vector. And also, like, if you check the camera, like, there are many different settings that you can manipulate, but I think the spring arm length and location, also this field of view would be enough, right? So let's add this field as well, field of view. Field of view, FOV. Right. So that's the default values. I would say the medium camera, like spring arm length 500, and then camera locations we can keep as it is. This field of view should be a float, and let's say the field of view, the default value is 90. Okay, then let's go to the data tables folder, and I'll create a new folder called camera, and there let's create a new data table by using that S camera settings data structure as the row type, and I'll call this one as dt underscore camera. Right, now I can add whatever the fields that I want. So just to get started with, I will add a new field, and I'll add a row name as maybe like medium camera, and we have this medium camera, close-up camera, aiming camera, far camera, and sprint camera, right? Yeah, maybe I'll set the medium camera as the camera state, and as the spring arm length for now let's add 400. Right, so ideally what I need is read this variable from the data table and initialize whatever the spring arm length that I have on the camera manager. Okay. So to do that, actually let's go to the camera manager, and we should have a way to actually read those data table values. Right, so to do that, I will add a new field called or new variable called actually camera state, or let's simply say, yeah, the camera state. This should be the type of camera state, and I'll make it as instant editable, and then assign it to a category called setup. Also, let's yeah, it should be fine. So let's create a new function called get camera settings. Right. So what this function essentially do is it consumes whatever the camera state that we requested as the input parameter, and it ideally should return camera settings. So it should be the type of S camera settings. Right. Now let's get the get data table row based on DT camera data table, and the row name I'm not quite sure. Instead of this one, since we are using this camera state, let's get the data table row names directly. Right, and the table should be the DT camera, and let's iterate through the names, and let's get the data table row based on the row name. Again, the data table should be DT camera, and here if we found the row, then let's check for its camera state. Colinum to the camera state, and so this should be this camera state and not this one. So it can be like misleaded if I kept the parameter name and the variable name as it is. Instead I will, so therefore I will make this one as current camera state. So you can see like we shouldn't ideally use this camera state as here. I'll remove this one. Instead I have to use this one, camera state, which is provided by this function. Right, so either you can actually drag and drop a pin like this, it would also work, but also like if you want to keep your code like sort of organized and clean fashion, then you can plug your parameters like this. Okay, so if I found it, then I can simply return the value. Right, I don't need to go through any of these values. I can simply return it. Right, and in case if I haven't found, it will go through this array and try to find the row. And in case if I haven't found anything, then at the completed stage I'm just simply returning a null return value as the camera settings. Right, ideally it would be the default values that you have been configured at the camera setting data structure. Right, so also I will make this one as pure function because it's doesn't modify any sort of variable within here, within this function. Right, and then let's go to the begin play, and here what we can do. So let's parameterize this target term length. Right, so I can configure this one at here. To do that, let's get this camera settings function and break it, and then the camera state, it should be the current camera state that I'm referring here, and the spring arm length should be the target arm length. Right. So currently the default state is medium camera. So ideally, according to the data table values, the spring arm length should be 400. Right? So let's test. Okay, it seems like the spring arm length is working properly and it's 400. Right. So now let's see what's the benefit of having this sort of a data table oriented structure, right? So let's say now I want to configure another camera, right? Maybe let's say close-up camera, and I'll rename the row name as close-up camera. And for instance, let's say when it comes to the close-up camera, the spring arm length is 3, I don't know, maybe like let's say 200, right? So this is just a random value that I've given just to test this thing. And now at the camera manager, all I have to do is simply change this current camera state to close-up camera. So ideally what it should do is it should get the appropriate camera settings by going through the relevant data table values, and it will return the settings to here and configure those stuff by using these functions, right? So there is no manual manipulations, right? Now let's test this thing. You can see the camera is now close up, right? And let's say I want to go back to the medium camera. I can set the current camera state. You can see that goes to the medium camera, right? So in that way, actually, you don't need to manually manipulate all of those values at runtime. Instead, you can configure those stuff at your data table. Plus, another benefit of having this one is, for example, let's say maybe you need to adjust these values later on, right? Maybe like when you are gameplay testing or whatever the stuff that you're doing at the development, maybe like let's say you find out the medium camera should be like 350. So you can easily tweak this stuff, easily set these values by simply tweaking these values at here, right? So that's the benefit of having data oriented architecture for the required components like these camera managers. Okay, so yeah, and just for testing these camera manipulations, I think we can add sort of a test stuff at our player base, right? So for now I'll add 1 as the debug key and 2 as another debug key, right? So ideally what I want to do is if I press 1, then it should go to the medium camera. If I press 2, it should go to the close-up camera, right? Okay, but to that first I need a way to get the camera manager. So for that, let's create a reusable blueprint function library, because later on actually not only within this player base actor, in other blueprint as well, in other instances as well, we can simply reuse that function instead of redefining it again. So I'll create a function called get player camera manager. This should be the type of it should be a pure function, and it should return a value called no, let's first get the player camera manager. Okay, so there are 2 functions, but ideally I need to get this one, This is the default function provided by the Unreal Engine. So we have somewhat similar naming convention here, but I think it would be fine. Right, so then let's cast to the BP camera manager. And then if we found it, let's return its reference. Right? Call this one as return value. And if we haven't found it, if we haven't casted it properly, then we can simply return the null reference. Right. Then let's go to the player base. And now I can get that thing. Get player camera manager. Right. So there are two different functions that is being shown at the hierarchy. The first one comes under BFL utilities, which is what we want, which is the custom function. And this one is the Unreal Engine provided functionality for getting the play camera manager. What I require is this one, get play camera manager. Okay. So then I think I should define another function to actually update the camera. Right. So I'll go to the camera manager and create a new function called set camera state. Right. And this should set the camera state like this, and after that it should update. So it currently update this one at here begin play, so I'll simply cut everything from there and push it to here. And then let's go back to the camera manager's begin play, and instead of attaching those stuff manually, I will use this function. So I'll have the total control. And then as the camera state, let's provide the current camera state. Also, I think at the set camera state, we shouldn't use this one. Yeah, but it would be fine because either way we are going to set the current camera state, so it would be fine. Right. Then let's go back to the player base, and I'll use that set camera state functionality. So if I pressed 1, it should set the camera state as medium camera. If I press 2, it should set the camera state and update the values accordingly for the close-up camera. Compile and save. Now let's play. Right, so you can see if I press 2, it goes to the close-up camera, and if I press 1, it goes to the medium camera. Right? So I can easily switch in between multiple different camera states, right? And all those values are properly configured at runtime. Right, so now we have basic set of camera transition to actually manipulate this target spring arm values of the camera spring arm. But well, actually this one is not quite perfect yet, because like you can see, like it's sort of snapping between multiple different state, right? Instead, actually what we can do is we can smoothen this state transition, right? So it won't like directly snap for a target target camera state. Instead, like it smoothly switch in between multiple different state, right? Anyway, so let's do those improvements on the next tutorial. See you there. Thank you.